Here is a matching type question. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us begin solving this step by step. Starting material, kiss smiley is a substituted cyclopentane bearing a phenyl group on a wedge bond, a methyl group on a dash bond, a bromo substituent, and an exocyclic alkene, vinyl allyl group. We analyze each reagent. A. H2O, heat, pH 7, neutral aqueous hydrolysis with heat. This is a mild SN1 solvolysis condition. The allylic bromide in kiss smiley undergoes solvolysis, allylic system assists. The product would be the allylic alcohol with retention racemization. This matches product C, cyclopentane with O on a plain bond and vinyl group, allylic alcohol. B, F3C, C is equal to O-O, trifluoroporacetic acid. This is a peracid which epoxidizes the alkene. The exocyclic double bond in kiss smiley is epoxidized to give an epoxide. Product D shows a cyclopentane ring with phenyl, wedge, methyl, dash, Br, and an epoxide ring, C is equal to O with O bridge shown. So, B, D, C, book, polar aprotic solvent, strong, bulky base in polar aprotic solvent favors E2 elimination. The allylic Br undergoes E2 to give a diene or extended conjugation. Product A is the allylbenzene diene product, no Br, extended alkene. So, C, A, D, 1, O3 ether, 2, H2O, now H, H2O2, ozonolysis followed by basic oxidative workup, Cre-G with H2O2 now H gives carboxylic acid from aldehyde. The exocyclic double bond is cleaved oxidatively. One fragment becomes a carboxylic acid. Product F shows Br, carboxylic acid, O is equal to CO, phenyl, methyl on the cyclopentane. So, D, Fe, Br2, CCl4, electrophilic addition of Br2 across the double bond, anti-addition. The exocyclic alkene adds Br to anti to give a vicinal dibromide. Product I shows 3 Br atoms total, the original Br plus 2 new ones from addition across the double bond, vicinal dibromide. So, E, IF, NBS, HV, CCl4, radical allylic bromination, NBS with light. This introduces a new Br at the allylic position. The existing allylic system gains another Br product. J shows a structure with 2 Br atoms on the allylic vinyl portion and retained double bond. So, F, J, G, 1, H3O plus 2, now H, H2O, acid catalyzed opening followed by base. This could be hydration of the double bond, Markovnikov, via acid catalysis, then base workup. The alkene is hydrated to give the Markovnikov alcohol. Product E shows an aldehyde, which could arise from rearrangement or the acid-base sequence on an epoxide intermediate opening to give hemiacetyl aldehyde. Actually, G, with H3O plus then now H2O on, kiss smiley with an allylic bromide, acid first could solvolyze the bromide to allylic alcohol or rearrange, now H workup then gives the aldehyde via oxidation level change. Product E, aldehyde on cyclopentane, fits. So, G, E, H, 1, BH3, ether, 2, H2O2, hydroboration oxidation of the double bond. Anti-Markovnikov addition of O. Product H shows the cyclopentane with phenyl, wedge, methyl, dash, Br, and an O on a plain bond, anti-Markovnikov alcohol. So, H, HI, 1, OSO4, 2, now H, H2O, osmium tetroxide dihydroxylthione, SYN addition of 2 OH groups. The exocyclic double bond gives a SYN diol. Product B shows the cyclopentane with phenyl, wedge, methyl, Br, and 2 of groups, diol. So, I, B, J, H to PDC, ATOH catalytic hydrogenation removes the double bond and can also hydrogenolyze the allylic CBr bond. Both the alkene and the CBr bond are reduced. Product G shows the cyclopentane with phenyl, wedge, methyl, and an ethyl propyl group, no Br, no double bond, fully saturated. So, J, G summary of matches. A, C, neutral hydrolysis, allylic alcohol. B, D, peracid epoxidation. C, A, E2 elimination to diene. D, F, ozonolysis plus oxidative workup to carboxylic acid. E, I, Br2 addition, vicinal dibromide. F, J, NBS radical allylic bromination. G, E, acid then base, aldehyde product. H, hydroboration oxidation, anti-Markovnikov O. I, B, OSO4-SYN dihydroxylthione, diol. J, G, hydrogenation, saturated product. Therefore, the correct answer is A, C, B, D, C, A, D, F, E. I, F, J, G, E, H, I, B, J, G. Therefore, the correct matching is A matches C, B matches D, C matches A, D matches F, E matches I, F matches J, G matches E, H matches H, I matches B, J matches G.